Okay, so just reiterating what we were saying on our last video here. We've got our parent function, and our parent function's up here. It's y equals b to the x. b is our base. Now, my x values that I'm going to use are -1, 0, and 1. I have to have those three values every time you graph your parent function on this. Okay? 0 is paired with 1. Because no matter what I have here for b, it doesn't matter if it's 1,000,000, it doesn't matter if it's 2. Okay? If I plug in a 0 for my x, your answer is always 1. Anything to the 0 power is 1. 1 will always go with whatever my base is. 1 will always be b, because anything to the first power is just itself. So if I have a 3 in here for b, my point down below here is going to be 1, 3, because 3 is my base. Okay, now -1, okay, -1, remember our negative exponents, we did this before, if I had 3 to the negative first, that negative made it move to the bottom, which made it 1/3. So we can say that our -1 is the reciprocal, and you can add down below, reciprocal of our base. So no matter what that b is, it's going to be the reciprocal. So if my b was 3, -1 would be paired with 1/3. Now if my b was 1/2, like it was on the slide below, remember the negative goes to both of them, okay, which causes them both to flip, gives me a 2/1, and I get 2, which if my base was 1/2, the reciprocal of 1/2 would be 2, okay? So your guys' parent function is going to have these 3 points every single time, and I would highly encourage you guys to draw this table off to the side to show how you got your points. Okay? So for this function over here, I left it as a b, left it as an arbitrary point. Let's pretend like that b was 3. Okay, so you could say y equals 3 to the x. Well, you're going to have your table, your x and y. Your x's are always -1, 0, and 1. So my base is 3. So 1 goes with the base, which would be 3. 0 goes with 1, because it always does. And -1 goes with the reciprocal, so it's going to be 1/3. So for this function, I'd have 1, 3, 0, 1, and -1, 1/3. And then you cannot forget, besides those 3 points, there's also an asymptote. Okay? So there's also an asymptote. And that is what my parent function is going to look like. Now, since our parent function can change, we're going to practice and draw a couple parent functions here. Okay, so if I look at my next one, next page here, I've got y equals 4 to the x power. First step, draw a table. -1, 0, and 1. Okay, so my base for this function, my base is 4. Now, when I'm filling out my table, 0 always goes with 1, so I can go ahead and start with that. 1 goes with my base. The base of this function is 4. Okay? -1 goes with the reciprocal of the base. So if my base is 4, its reciprocal would be 1/4. Okay? So I've got my 3 points. I'm ready to graph 0, 1, 1, 4, -1, 1/4, and then do not forget, you've also got a horizontal asymptote. Okay? Once I have those 3 points in that asymptote, I'm ready to draw my line. Okay? Let's do one more example. This one over here. The base of this exponential function would be 1/4. I still draw my table, x and y. -1, 0, and 1 are always my x values. -1, 0, and 1 are always my x values. 0 always goes with 1. 1 goes with my base, which we said our base for this one was 1/4. -1 goes with the reciprocal of the base. So if my base is 1/4, its reciprocal would be 4/1, which is just 4. So I'm going to graph them, -1 and 4, 0 and 1, 1 and 1/4. Besides those 3 points, do not forget it has a horizontal asymptote. And I'm just going to draw my line. Make sure I hit all my points. Okay? So that's graphing our parent function. Make sure you draw a table. It's going to help you out a ton. Okay? Now, besides our parent function, we also have to worry about shifts. Remember, inside is horizontal. Outside is vertical. Okay? When we are shifting on the inside, we do the opposite. Okay? And then the last one, our negatives, are going to cause our graph to flip. It doesn't shift it up or down or left or right one. It causes them to flip. Okay? Now, this function is a little bit different. It's going to have a base value. That base does not affect any of the shifts. Base does not affect any of the shifts. Anything out in front of the base or anything back behind the base are going to make it move. The only way you have a horizontal shift if it is actually up in the exponent. Okay? The font is going to be smaller if it is a horizontal shift. Okay, so let's look at a few of these. I've got y equals 3 to the x power minus 2. Okay, now I'm going to flip back and forth. That minus 2 is on the outside. That plus 2 is on the inside. So I want you guys to look at the difference. Look up here at the function. That plus 2 is on the inside. Minus 2 is on the outside. Plus 2 is on the inside. Minus 2 is on the outside. I hope you guys can see the difference on the inside and the outside on that. This plus 2 is actually up in the exponent. You can see it's small with the x. It's up in the exponent. This minus 2 is bigger. Okay, it's on the outside. It's on the same level as the 3. Okay, so starting out, what's my parent function? What's y equals 3 to the x power? Let's draw our table. X, y, negative 1, 0, and 1. Okay, 0 always goes with 1. 1 goes with our base, which in this case, our base would be a 3. Negative 1 goes with the reciprocal. That's going to be 1/3. Okay, so I'm going to graph those points there. Negative 1, 1/3, 0, 1, 1, 3. Do not forget your asymptote. Okay? Next, I'm going to have my shift. If you guys notice, this negative 2, it's on the outside, so that means it's going to be vertical. Okay? And it's going to move down 2. Oops, I forgot to connect or actually draw my function here. Okay, so that means each of my points, along with my asymptote, is going to shift down 2. So that's what a vertical shift will look like on this function. Okay, that's our vertical shift. Now let's graph our horizontal shift. I've got y equals 3 to the x plus 2 power. So I'm going to start out with my parent function again. Y equals 3 to the x. I've got x, I've got y, negative 1, 0, and 1. 0 always goes with 1. 1 goes with our base, which again in this case is a 3. Negative 1 is the reciprocal of the base. The reciprocal of 3 would be 1/3. Okay, I'm going to graph my points. And I'm going to add my asymptote. Don't forget to draw your line as well. Okay, now I'm going to graph y equals 3 to the x plus 2. Okay, notice that plus 2 is up in the exponent. This is on the inside. This is on the inside. Remember, our inside would do the opposite as well, so this is going to shift it to the left 2. Okay, my asymptote shifts to the left 2, but it's an infinite line, so it doesn't really look like it does. Okay, each of my points also shift to the left 2. So there's an example of a horizontal shift for you guys. Then let's look at our flips. Okay, parent function is y equals 4 to the x. I've got x, y, negative 1, 0, 1. 0 always goes with 1. 1 goes with our base, which is 4. Negative 1 goes with the reciprocal of the base, which is 1/4. So I'm going to go negative 1/4, 0, 1, 1/4. Do not forget your asymptote. Okay? So there's our parent function there. Now notice on this one, okay, this negative is on the outside. Okay? Remember, the only way that a negative is on the inside is if it is actually up in the exponent. Okay? So this right here, that negative is on the outside, this is a vertical flip. Which, remember, when we're flipping, we're not paying attention to the axes. This is a vertical flip, meaning that my points are going to flip down. Okay? That's a vertical flip. So my asymptote will stay in the same spot, but each of my points will have flipped down below that asymptote. We're not paying attention to the axes. We're watching how the points are moving. Okay? If you were going to have a horizontal flip would have looked like this. See how the negative is up in the exponent? This would be horizontal. Okay? So I think we've got one more function that we need to graph here. And it's a multi-step one. Okay, remember with our multi-step ones, we want to go inside, out. So that means I'm going to start with my parent function, y equals 3 to the x. Then I want to do the shift that's on the inside. So my next shift is going to be y equals 3 to the x minus 3. And then finally, I'm going to deal with that last outside one, 3 to the x minus 3 minus 4. Okay? So we've graphed this y equals 3 to the x as parent function enough. I'm not going to draw the table. I've got 0, 1, 1, 3, negative 1, 1/3. Do not forget your asymptote. Okay. Then I've got y equals 3 to the x minus 3 power. So that is a horizontal. That's inside. Okay, so it's going to move everything to the right 3. Each of my points moves to the right 3. Okay. And then my last shift is this negative 4, which is on the outside. So that's going to be a vertical shift. It's going to cause this to move down 4. So I'm going to have each of my points now shifted down 4. Okay. So there's our shifts that we're going to have for lesson 47. We now have all of our parent functions. Here pretty quick. Next time or the time after that, I can't remember. You guys are going to take your last free slow quiz. Okay, it won't be for a grade. But you guys will definitely want to make sure that you are starting to get these down. Okay, because we're going to start getting quizzed over them. But go ahead and finish your guys' lesson practice. After you finish your lesson practice, you guys can work on your homework. It's on the back of this. Good luck.